Hello my friend, happy to see you here, and really interesting Olympiad problem with factorials. We have x factorial equal to x cubed minus x. Maybe a little bit different problem from the other ones, because we don't like factorial, we have cube factorial. This is not like a common problem, this is not like a general problem that we really like to solve it, but I want to show you a really good tricky approach how can we do this. So first of all, we don't need this factorial. This is really bad that we have factorial right here in this equation. It looks like cube equation, but we have this factorial. What are we going to do with this? Take a look closely. I want to write a really interesting explanation. So for example, we have 5 factorial. How can we write it? We can write it as 5 times 4 times 3 times 2 and times 1. Yeah, we can write it as a product. But moreover, this 3 times 2 times 1 we can still write as 3 factorial. Yeah, we can write it as 3 factorial. So as a result, it can be written like 5 times 4 times 3 factorial. So we don't need to multiply it, don't need to write it as a product. So we can let this right here, leave it in this way that we have right here. And I hope you understand this moment, because this is maybe the main moment right here. Because if we have like x factorial, how can we rewrite it? So it goes like x times the previous one. So right here we have, for example, this is our x. Then 4, this is a previous one, so times x minus 1 times x minus 2 and times x minus 3. But I want to write it, for example, as x minus 2 factorial. I don't want to write all of these elements with this product. I want to leave it in this way. Yeah, so this is our 4, but this is example to this 5. But this case works to every x, so this is our x factorial, as you can see. So 5, and right here 5, previous one, the previous one with factorial, and this is maybe explanation to the first step. So in the first step we change this x factorial by this expression. So we have like x times x minus 1 times x minus 2 equal to x minus 2 factorial equal to x times, right here I just want to factor this x, okay? And in parentheses we will have like x square minus 1, yeah? So x square minus 1. This is the step on the right hand side. I factored this x. Okay, and take a look closely what we will have right now. We can easily cancel this x. So let's write the next step. So x minus 1, we still have x minus 1, x minus 2 factorial equal to x square. And I want to write this one as 1 square. And it's not hard to see that this is our identity formula. A square minus b square, which is equal to a plus b times a minus b. Yeah, this is our school identity, we need to know it. And as a result, let's use this identity. We have like x minus 1 times x minus 2 factorial equal to x minus 1 times x plus 1. Yeah, and if you look closely, all-time product, and we can easily cancel this x minus 1. So as a result, our final equation right here, so x minus 2 factorial equal to x plus 1. After all simplifying step, we have this equation. And right now, this is really good to simplify this a little bit, because we don't need this x minus 2 factorial. This is not like a good for us. So let use a substitution. So let this x minus 2 will be equal to, for example, y. Yeah, so from here, x equal to y plus 2, and if we add 1, we will have like x plus 1 equal to y plus 3. So we have all elements that we need to change. We have x minus 2, x plus 1 right here, so we can easily change it with y. So we have like y factorial equal to x plus 1 equal to y plus 3. Okay, I hope you understand this step. And right now let's bring this y to the left hand side. We have like y factorial minus y equal to 3. Yeah, equal to 3. Okay, take a look closely what we're gonna do next. Let's write this y factorial in the same way in the beginning. So y times y minus 1 factorial. Yeah, so I want to write this y factorial as well like that. Minus y equal to 3. And right now we have y and we have y. So we can easily factor this y real quick. So we have like y, and in parentheses we will have like y minus 1 factorial minus 1 equal to 3. So I hope you understand this step. Okay, let's go next. I want to write right here on the top, we have this expression, y minus 1 factorial minus 1, we multiplying it by y, and equal to 3. And right now let's divide by y both sides. If we divide it, we will have the next one. We will have that y minus 1 factorial minus 1 equal to 3 over y. Yeah, equal to 3 over y. And right now let's add to both sides this one, because we don't need it right here. We have y minus 1 factorial equal to 3 over y and plus 1. And as you can see, we like simplify this, or we rewrite this equation, this is the beginning, in this way. And this is maybe the main important expression that we need to solve this interesting problem. Because we have factorial on the left, this is really good, and we have a more simplifying expression than in the beginning. Okay, I want to mention one really interesting moment, that right here y minus 1. So y need to be greater or equal than 1. This is really interesting and really important moment. So we need to check only when y is greater or equal than 1. So let's try to suppose it real quick. Let's suppose, for example, that y equal to 1. Okay, what we'll have, like 0 factorial equal to 3 over 1, so 3 over 1 and plus 1 equal to, right here we'll have 3 plus 1, 4. 0 factorial is not equal to 4, so this is incorrect. Yeah, so this is the first supposition, that y equal to 1. Let's go next. When y equal to 2, for example, I read here like that, so y equal to 2. So what we will have, that 1 factorial equal to 3 over 2 plus 1 equal to, right here 3 half plus 1, we will have like 5 half or 2.5, which is absolutely incorrect, because 1 half is not equal to 5 half. This is incorrect. Okay, let's go next. Y equal to 3. When y equal to 3, what we will have as a result? We will have like 2 factorial equal to 3 over 3 and plus 1, which is equal to 2, because we have like 1 plus 1 equal to 2 and 2 factorial equal to 2. This is really good. We finally find our y equal to 3. Okay, let's go next. We find our y, but what about our x? Because we solved it in the beginning with x's. So let's try to plug in. We have, for example, x minus 2 equal to y. So we have x minus 2 equal to y, and we know that y equal to 3. Yeah, so what we will have as a result? We will have from here that if y equal to 3, we need to have x equal to 5. X equal to 5. This is our solution. But what about solution? Let's check it real quick, because this is really interesting. This is maybe a tricky moment, and this is moment maybe bigger than in inspection moment, because right here we have a supposition. We not like solve it like a quadratic equation, like a cubic equation. It's not. It's all about our suppose. But for example, if x will be equal like 50, yeah, we cannot like find a 50 factorial or can divide it. This is a long, yeah. So this is out about this method supposition. But let's try to check our root real quick. So what we'll have as a result? We'll have 5 factorial equal to 5 cube minus 5, yeah. So what we will have, like 5 factorial, we know that this is a product from 1 to 5, we have like 24 times 5, we'll have 120 equal to, right here 5 cube, 125 minus 5, yeah, 120, so our answer, x equal to 5, this is our solution. Really interesting question. I like this question so much, because this is a tricky question with factorials. This is not like a question with for example, only our x, when we have like x equal to x cubed minus x, real quick, like cube equation, you can easily solve it. This is question with factorials, and I hope you will enjoy these steps right here and right here. Because if you don't know this step, you like can solve it by inspection, but it will be like only one line, and it's not like a solution to this problem. If you want to solve it, you need to write many lines. Like if the question is complicated, you need to solve it. You need to write a lot of lines right here. But if you want to solve it by inspection, at first one line, and this is like not a good solution to this problem. This is my approach. What about you? Write your suggestion in comment. Maybe you solve in another way, and maybe you have your really good approach. It will be really interesting to read about it. Thank you so much for watching. See you in the next videos. Have a great day.